All right, let's make some decision trees. It's pretty easy. In fact, it's crazy how easy this is. It's pretty exciting stuff that we can just create an actual flowchart from training data that really works with just a few lines of code in Python. So let's give it a try. So I've included a pasthires.csv file with your course materials, and that just includes some fabricated data that I made up about people that either got a job offer or not based on the attributes of those candidates. So go ahead and change that path to wherever you installed the materials for this course. I'm not sure where you put it, but it's almost certainly not there. So go ahead and edit that file. We're in the decision tree IPython notebook file here right now. And we're just going to use pandas to read that CSV in and create a data frame object out of it. Okay. So let's go ahead and read that in. And we can use the head function on the data frame to print out the first few lines and make sure that it looks like it makes sense. And sure enough, we have some valid data here. So for each candidate ID, we have their years of past experience, whether or not they were employed, their number of previous employers, their highest level of education, whether they went to a top-tier school, and whether they did an internship. And finally, here's the answers where we knew that we either extended a job offer to this person or not. Okay. So as usual, most of the work is just in massaging your data, preparing your data before you actually run the algorithms on it. And that's what we need to do here. Scikit-learn requires everything to be numerical. So we can't have Ys and Ns and BSs and MSs and PhDs. We have to convert all those things to numbers for the decision tree model to work. So the way I'm doing that is using some shorthand in pandas, which makes these things easy. Basically, I'm making a dictionary in Python that maps the letter Y to the number 1 and the letter N to the value 0. So I want to convert all my Ys to 1s and Ns to 0. So Y will mean 1 will mean yes and 0 will mean no. And what I can do is just take the hired column from the data frame using this syntax here and call a map on it using a dictionary. And what that will do is go through the entire hired column in the entire data frame and use that dictionary lookup to transform all of the entries in that column. And it returns a new data frame column that I'm putting back into the hired column. So this basically replaces the hired column with one that's been mapped to 1s and 0s. Okay. And I do that same thing for employed, top tier school, and intern. So all of those get mapped using the yes-no dictionary. So the Ys and Ns become 1s and 0s instead. For the level of education, I do the same trick. I create a dictionary that assigns BS to 0, MS to 1, and PhD to 2, and uses that to remap those degree names to actual numerical values. So if I go ahead and do that and do a head again, you can see that it worked. All my yeses are 1s, my nos are 0s, and my level of education is now represented by a numerical value that has real meaning. So now we just need to prepare everything to actually go into our decision tree classifier, which isn't that hard. To do that, we need to separate our feature information, which are the attributes that we're trying to predict from, and our target column, so what contains the thing that we're trying to predict. So to extract the list of feature name columns, we are just going to say create a list of columns up to number 6, so the first 6 columns. And we go ahead and print that out. And those are the column names that contain our feature information. Years experience, employed, previous employers, level of education, top tier school, and intern. These are the attributes of candidates that we want to predict hiring on. And we next construct our Y vector here is assigned to what we're trying to predict. So that is our hired column. So this extracts the entire hired column and calls it Y. And then it takes all of our columns for the feature data and puts them into something called X. So this is a collection of all of the data and all of the feature columns. And these are the two things that our decision tree classifier needs. So to actually create the classifier itself, 2 lines of code. We call tree.decisionTree classifier to create our classifier, and then we fit it to our feature data and the answers, whether or not people were hired. So let's go ahead and run that pretty quick. Now to display it, I don't want to get too much detail what's going on here. Basically, displaying graphical data is a little bit tricky. Just consider this boilerplate code on how to do this. You need to understand how graph works and dot files and all that stuff, but it's not important. Basically, this is the code you need to actually display the end result of a decision tree. So let's go ahead and run that. And there we have it. How cool is that? We have an actual flowchart here. Now let me show you how to read it. So at each stage, we have the decision. So remember, most of our data is yes, no. It's going to be 0 or 1. So the decision point here is employed less than 0.5, meaning that If we have an employment value of 0, no, we're going to go left. If employment is 1, yes, we're going to go right. So were they previously employed? If not, go left. If yes, go right. And it turns out that in my sample data, everyone who is currently employed actually got a job offer. So I can very quickly say, if you are currently employed, yes, you're worth bringing in. We're going to follow down to this level here. So how do you interpret this? The Gini score is basically a measure of entropy that it's using at each step. Remember, as we're going down, the algorithm is trying to minimize the amount of entropy. And the samples are the remaining number of samples that haven't been basically sectioned off by a previous decision. The way to read the final leaf nodes here are this value column. So that tells you at this point we have 0 candidates that were no hires and 5 that were hires. So the way to interpret this is if employed was 1, I'm going to go to the right, meaning that they are currently employed. And this brings me to a world where everybody got a job offer. So that means I should hire this person, okay? Now, let's say that this person doesn't currently have a job. The next thing I'm going to look at is, do they have an internship? If yes, then we're at a point where in our training data, everybody got a job offer. So at that point, we can say our entropy is now 0 because everyone's the same, and they all got an offer at that point. However, if we keep going down, we're at a point here now where the entropy is 0.32. It's getting lower and lower. That's a good thing. So next, we're going to look at how much experience they have. Do they have less than 1 year of experience? And if the case is that they do have some experience and they've gotten this far, they're a pretty good no hire decision. So we end up at this point where we have 0 entropy, but all 3 remaining samples in our training set were no hires. Okay, we have 3 no hires and 0 hires. But if they do have less experience, then they're probably fresh out of college. They still might be worth looking at. The final thing we're going to look at is whether or not they went to a top tier school. And if so, they end up being a good prediction for being a hire. And if not, they end up being a no hire because we end up with 1 candidate that fell into that category that was a no hire and 0 that were a hire. Whereas in this case, we have 0 no hires and 1 hire. So you can see we just keep going until we reach an entropy of 0, if at all possible, for every case. Now, let's say we want to use a random forest. We're worried that we might be overfitting our training data. It's actually very easy to create a random forest classifier of multiple decision trees. So to do that, we can use the same data that we created before. Again, you just need your x and y vector, the set of features, and the column that you're trying to predict on. And we're just going to make a random forest classifier, also available from scikit-learn. And all you need to pass it is how many trees do you want in your forest. So let's make 10 trees in our random forest. We can then fit that to the model. And you don't have to walk through the trees by hand. And when you're dealing with a random forest, you can't really do that anyway. So instead, we're going to use the predict function on the model, on the classifier that we made. And we're going to pass in a list of all the different features for a given candidate that we want to predict employment for. So if you remember, this maps to these columns: years experience employed, previous employers, level of education, top tier school, and interned, interpreted as numerical values. So if we want to predict the employment of an employed 10-year veteran, we can do that. Or we want to predict the employment of an unemployed 10-year veteran, we can do that. And sure enough, we get a result. So in this particular case, we ended up with a higher decision on both. But what's interesting is there is a random component to that. So you don't actually get the same result every time. More often than not, the unemployed person does not get a job offer. And if you keep running this, you'll see that's usually the case. But the random nature of bagging, of bootstrap aggregating each one of those trees, means you're not going to get the same result every time. So maybe 10 isn't quite enough trees. So anyway, good lesson to learn there. For an activity, if you want to go back and play with this, mess around with my input data. Go ahead and edit that CSV file that we started from and create an alternate universe where it's topsy-turvy world. Everyone that I gave a job offer to now doesn't get one, and vice versa. See what that does to your decision tree. Just mess around with it and see what you can do and try to interpret the results. So have some fun with it. This is interesting stuff, I think. This is really cool. So that's decision trees and random forests. So that's decision trees, one of the more interesting bits of machine learning in my opinion. I always think it's pretty cool to just generate a flowchart out of thin air like that. So hopefully you'll find that useful. Let's move on.